Hello, this is Scott Dahman, Director of Business Development at PowerWorld Corporation. In this section, we will take a look at the PowerWorld Simulator Case Editor and also look at how one-line diagrams can be used to interact with a PowerFlow case and to edit a PowerFlow case. But first, we'll provide a little bit of a background behind our company, PowerWorld Corporation, and also some of the origins of the PowerWorld Simulator software. The PowerWorld Simulator software is a user-friendly and highly interactive power system analysis and visualization platform. It has PowerFlow as its core function, and then many other analysis functions are applied on top of that, including things like linear sensitivity analysis, contingency analysis, available transfer capability analysis, and many more. The software runs exclusively on Microsoft Windows on operating systems from 2008 and newer, both server and client versions, but 64-bit editions only. Older versions of PowerWorld Simulator worked on 32-bit editions of Windows. PowerWorld Simulator integrates the PowerFlow package with its add-on tools with a graphical case editor, which we refer to as one-line diagrams. PowerWorld Simulator was originally developed as a teaching tool by one of our founders, Professor Thomas Overby, who was at the time at the University of Illinois at Urbana-Champaign. He is now a professor at Texas A&M University. The motivation early was to teach power system operation to both students of power engineering as well as non-technical audiences. Our company was established in 1996 with the goal of further developing and commercializing PowerWorld Simulator. We're now up to version 23, which is virtually unrecognizable from the early versions of the software. It's evolved into a powerful commercial power systems analysis package. Some key goals of this training are to provide a better understanding of how to use PowerWorld Simulator for system analysis and visualization, and to provide opportunities for hands-on examples if you wish to participate. We'll be doing several examples in this topic and in other topics where you can follow along with the same cases that we use. The overarching goal is to make you aware of the capabilities of PowerWorld Simulator and to give you some familiarity with them. It's certainly expected that after you complete training, you'll be able to do some analysis on your own, but you may have some questions that come up in the future. And you can feel free to contact us if you have specific issues that come up that are not covered in the training, with the caveat that technical support is reserved for customers with current maintenance agreements. In this next section, we'll talk a little bit about the PowerWorld Simulator interface and also go through an example of opening and working with a case and with one-line diagrams. PowerWorld Simulator works with a lot of industry standard PowerFlow case formats. For example, the PTI PSSE RAW format, the GE PSLF EPC format, several text-based EMS formats, and several others. It should be noted that all of these are text-based formats and not binary formats. PowerWorld Simulator can read its own binary format, the PWB, but it can't read other binary formats like the PSSE save format. PowerWorld Simulator uses the ribbon interface, which is common to a lot of Microsoft applications. Microsoft Office, for example, Excel and Word have a ribbon interface, and it should feel pretty familiar to anyone who uses these applications. There's a file menu in the upper left that'll bring up a drop-down, and then a lot of these other menus right here will reveal a ribbon that has different functions on them related to what's described up here in the ribbon. Some of the commonly used functions occur up here in what's called the quick access toolbar. And you can right click in this region to take things off of the quick access toolbar, or you can right click on a function in one of the other ribbons that's not on the quick access toolbar and add it to the quick access toolbar. There's also a help button, which is always available, and you can get to help by pressing the F1 key. Again, these are all functions that are pretty standard across a lot of Microsoft applications. And as I mentioned, if you pick a different ribbon tab, then it'll reveal a set of functions that are pertain to that group. Like for example, on tools, you have a lot of these analysis tools that are in the base package of Simulator, such as contingency analysis and fault analysis. You can solve the power flow, you can open the options dialog, and we'll see several examples of these functions in this section. And here's a description again of the quick access toolbar. So things that you find that you use often, if they're not already up there, you can right click on any button down here and add it to the quick access toolbar, or you can right click on anything that's already up there and remove it. Power flow data that's common in a lot of those text file formats that you can open in Simulator provides a static model of the power system. So there's a system state, there's basic objects like buses and generators and loads, transmission lines and transformers, and a description of how they're all interconnected. For a lot of simple studies, that's what's in the raw file or the EPC file, for example, would be sufficient. Other times you might need to import some other data, things like generator cost information, reactive power capability curves, again for generators. You might need to alter the options that are used in the solution of the power flow. You might need to bring in some higher level objects like interfaces, which are also sometimes called flow gates in the industry. Injection groups are groups of generators or loads or other megawatt or megavar devices that can be used in other types of analysis, like available transfer capability analysis, PVQV analysis, things like that. Typically, that's not going to be in the raw file or the EPC file either. You can add that information after you've loaded those files. And contingency definitions is another example. Those might occur in other industry standard file formats. And this is just a sampling of the types of data that you might need to or want to bring in and add to the power flow case. So a flow chart for the process that you might go through to do some power systems analysis might look like this, where you open a power flow case from an industry standard format, things that are available again like raw files, EPC files, maybe an EMS model. You might wish to graphically create a one-line diagram. The one-line diagrams would typically be separate files. We have a binary file format for storing one-line diagrams, and we'll see kind of the relationship between the one-line files and the case files a little bit later. But it's optional. You can do a lot of analysis without using one-line diagrams, but they can be very helpful for visualization and also just as another way to interact with the case. And we'll see that in the example that we do in a moment. You might need to augment and modify the case, for example, bringing in some of that other data that we talked about, maybe making some changes to some settings. Once you've done a little bit of that work, you might want to save the case into a binary so that it encompasses everything that you've done up to that point, as well as saving perhaps a one-line diagram if you created one into a binary file. Then you might want to proceed with doing some studies, saving along the way, and then if you need to export it into a format that can be read by others in the industries that may or may not have PowerWorld Simulator. So a display file or a one-line diagram is related to the objects in the system model, as we'll see in the example we do. The power flow data that's included is kind of a subset of the whole system model. And in a future section in the training, section I3, we'll look more closely at text-based case information displays. we'll touch on them a little bit in this section, and some of their features are kind of embedded in different parts of Simulator, as we'll see. But one-line diagrams can optionally be created, and they can also be used with different cases. So there's not a one-to-one correspondence necessarily between a one-line diagram and a case. You can have a single one-line diagram that's used by multiple cases, or within a single case, you might have multiple one-line diagrams that have different features shown on them.
This next slide just shows that relationship graphically. So the user can interact with PowerFlow case using a bus view one-line diagram, one-line diagrams that you create, or case information displays. And you can have multiple instances of each of these operating. Furthermore, within a single one-line diagram, one-line objects don't necessarily have to have a one-to-one mapping. You can have multiple representations of the same object, such as a bus or a transmission line, on the same one-line diagram. It's a powerful approach, but it does introduce some ambiguity when you're deleting objects. So when you go to delete from a one-line diagram, you have the option of deleting just the display object or deleting the display object and the underlying model object. Next, we'll do a hands-on example where we open a 2000 bus synthetic model that is representative of the Texas power system. And I'll go ahead and launch PowerWorld Simulator right now. And then choose File, Open Case. Navigate then to where your training cases are stored. And if you want, you can also choose which types of files to display. The default is common file types, which will show the PowerWorld binary. It'll show raw files, EPC files. Or you can also pick which specific types of case you wish to open. Like, for example, the GE EPC format, which we'll be using here. If I choose that from file type, then I'll only see files of the EPC type. I can choose Active SG2000 and then click Open. And the message log tells me that the case is successfully opened. I find it very helpful to have the message log open when you're doing things like opening a case or solving a PowerFlow case, just to make sure that everything works correctly and there's no errors. So it tells me down here that the initialization is complete. If I wanted to, for example, I could solve the PowerFlow. We can do that with the button right up here on the Quick Access toolbar, or from the Tools ribbon, we can click the calculator icon. And as you can see, if I mouse over, then I get a hint as far as what this is. If I click that, then the message log tells me that I have a successful PowerFlow. So for now, I'll close it. And then I'll go to File, New One Line. And this will automatically switch me to edit mode so that I can place objects on this new one line. The next slide here describes that we have an edit mode and a run mode, and the mode is always visible on the left edge of the ribbon, regardless of which ribbon tab you've selected. The next slide describes solving the case, which I did when after I opened it. And like I mentioned earlier, if you switch to the message log, then you can see the progress of the solution and make sure that it solves correctly. This is usually a great idea anytime you're opening a new case. Case information displays are primarily a topic in another training section, but right here we'll look at just a couple examples. So one of them is the case description, and I go to the case information ribbon tab and then open case description. Click on that. Then I'll see right here. It just provides some notes down here about the case, and it's typical in EPC or raw file formats that you would see some information here that describes the case, what part of the system it models, maybe who created it. We've got some details here about this synthetic PowerFlow case. The raw file format, I believe, still only supports 2 lines of text here, but other formats support additional lines. Also in PowerWorld Simulator, we have this case comment section. You can add a comment to a case at any time by going here and right-clicking down here in the case information display and choosing insert. You can add a comment. You can also, in many circumstances, when you go to save a case, you'll be prompted, if this box is checked right here, to add a comment at the time that you save it. There's also a case summary display right below the case description. If I click that, I'll see some basic statistics about what's in this case. So there's 2,000 buses in the case. Here's numbers of other objects that occur in the case, where the path is, some statistics about the total load and the total generation in the case, real and reactive power, shunts, losses, distributed generation, other things like that, and also a mention of where the slack bus is located. And there should be a slack bus for each electrical island in the case. This case has just one, and so there's a single slack bus. This slide just describes some of the features on that case summary dialog. So as we described, the summary of load and generation, etc., the slack bus. You can also, on a lot of dialogues, open up a help topic, or at any time just press the F1 key and it'll give you context-sensitive help. This is a read-only dialog too, so if you need to edit things like the slack bus, you would go elsewhere to do that. We also have a PowerFlow list display, which is also on that same case information ribbon tab. This is kind of de-emphasized in PowerWorld Simulator because the bus View Oneline is so much more powerful, but if you're familiar with it from use in other software, it's available here too. And this is just an example of what it looks like. So it just gives you a list of buses and then the flows that go to either connected devices like loads, generators, and shunts, or down transmission lines that are connected to each bus. The quick PowerFlow list is a variant of that where you can just pick certain buses that you want to view instead of looking at a list of everything in the power system. And here it just describes how to use that. You can enter a single bus or a range of buses right here, click show, and then it'll display the data down here. The bus View Oneline diagram is a graphical representation of the quick PowerFlow list. It's much easier to use, and you can navigate from bus to bus using the features in there. So back in Simulator, from the Case Information ribbon tab, I can just open Bus View right here. And if you're not on a bus already from a case information display or some other context, it'll look blank like this, and you can just type in a bus number if you know where you want to go, or if you're not sure where you want to go, you can open the Find menu and then choose a bus from the list. And then I can click OK. And so the active bus is this Big Spring bus that I've chosen, number 1006. And it shows that it has a generator connected to it, the output of that generator, a representation of the transformer, the step-up transformer that connects that bus to a higher voltage bus in the substation. And I can click on other buses and it'll update the display to show the view from that bus. So, and I can also see there's a graphical representation of the power flow with arrows that show whether the power flow is going into or out of that bus. And there's some other displays that show the system state for that bus. It's 1.01 per unit voltage magnitude, the kV of the voltage, and the angle of the voltage. And the next display is a optimal power flow quantity for the megawatt marginal price. That's not valid because we haven't solved the optimal power flow, so that's why that's shown. And then we also see real and reactive flows again to each line, and then also the bus voltage magnitude and kV voltage of the neighboring buses. And these quantities are all stored in an option set that you can go under views right here and see they belong to the system state view, basically. I can switch this to input data instead, and then all the fields will change to show characteristics like the impedance parameters and limit parameters of the lines, and some of the other stuff. It looks like the number, the non-kV, is shown here for the buses instead of the actual kV. And if you want to create your own view, you can do that as well. Under views, you can choose define custom view. And then here you can specify which fields you want to show for each object type. So for example, let's say for the generator, I wanted to also show the power factor. I can just choose modify up here, and instead of the megavars, which is one of these common fields that are shown here, and the more common ones have their own buttons out here. If I wanted to do something that's aside from that, like the power factor, I could choose find field right here, and then just type, for example, power factor as a search term, and then hit enter. It'll jump to the next field that matches. And if that's not the one I want, I can hit enter again. And here, this is the one I want under MVA output, power factor. Just choose OK. And then OK again. And then it replaces that field there. So for generators and loads, I can choose up to 2 different fields. You can also remove a field that you don't want. For transmission lines, you can choose up to 8 fields and so forth. This is for like the neighboring bus right here. So once you make the changes you want, you can choose switch to custom bus view, and it'll prompt you to give it a name. So I can just call it, Gen PF, for example, click OK, and then I'll bounce back out to it, and it'll show me that I'm on that display setting, Gen PF. And here I can see that I've got the power factor for that generator, and then it becomes one of my choices right here. So you can define as many custom ones as you want. They'll just show up down here. The standard input data and system state will always be visible right there. You can also choose some different options, like, for example, number of tiers. This is on the options drop down here. I can change that from 1 to 2. And when I do that, instead of just showing the next bus that's connected to the active bus, it'll show the connections to that bus as well. And you can click on any of these to like jump out there. So silver one, I click on that. I'm taken to that bus. It's a 115 kV bus that has a couple of loads, a transformer up to 230 kV in that same substation, and some connections at 115 kV and so forth. So you can navigate like that. There's some other options for when you click on the bus view dialog again. Do you want it to always open a new one, or just switch back to the one that's already open, or do you want it to prompt? So if I click bus view, it'll tell me, hey, there's one that's already open. I can choose yes, and it'll just open another window. Both of them will be open. If I choose no, it'll just bounce me back to the one that was there. So you can change that setting there with multiple bus views. Layout options, it has a bunch of things that you can check or decheck, and so forth. And those are all described on the slide in greater detail. So showing hints, like you mouse over an object, it'll give you the hint. That's usually pretty helpful. History will show like all the buses you've clicked through already to this point. They'll be showed there. So if you want to go back to an old one that's not necessarily on the current view, you can do that. And then, as we saw earlier, we can find a specific bus, and then also kind of like the browser back and forward function. You know, you can just go back that way. So that's kind of a variant on the history. You hit the drop down and you can go back and forward 1 or 2 or 3 or how many ever steps that you want. So going back to the slides, we can see a description of some of these features right here on this slide, the back and forward buttons and the information and the find and all those features that we just looked at. And this is shown with multiple tiers right here and some other features. The colors of the buses and the transmission lines are governed by default drawing values. We'll take a look at that later. And then this also just points out that on the buses that are not active but are the neighbor buses, there are symbols that show whether there's the presence of load generation or shunts at those buses. And then these are the options that we talked about. These are some greater detail given for each one of those. And then also you can define a custom view, which we just described, or you can switch back and forth between the predefined input data or system state, and any custom views you create will be shown at the bottom. And then this is just screenshots of the input data and system state examples. And then this is the dialog, which describes how you can edit or create a custom bus view by changing the fields that are displayed at each position. In this next section, we'll look at creating our own one-line diagram with the 2000 bus case. A key point here is that a diagram needs only be created for a subset of the system. If you like, you can put the entire system on the one-line diagram, but you only need to build out the parts that you're interested in visualizing. Regardless, Simulator will model the entire system in the PowerFlow and other calculations. When you open a one line, it will automatically try to link that one line to the loaded power system case. And the one line diagram can be used to actually modify the underlying case if you like. The first step would be to go to the File menu and choose New One Line, which we've already done. The next thing we'll take a look at is automatically inserting some geographic borders. So over in Simulator, make sure that the one-line diagram, new one.pwd, is the active window. Or if you haven't already done that, you can just go to File, New One Line. And so from here, we'll switch to the Draw Ribbon tab, and then choose Auto Insert Borders. And Simulator's got a bunch of built-in geographic borders, and it defaults to the library here. We've got borders for the United States, for Canada, and for the entire world. Within the United States, you can put in individual state borders and also county borders within each state. Since we have a Texas model, let's scroll down on the United States tab and choose Texas. If you want, you could just select all of them and put all states on. It's also worth noting you can repeat this process. So if you insert US borders, you can go back and insert Canadian borders or borders for other countries as well. But here we'll just do this example with Texas, and I'll leave it on the state border type. And then down here you choose a map projection. And Simulator's got 3 built-in map projections, which basically define how the 3-dimensional surface of the Earth gets projected onto the 2-dimensional screen. For North America, you can use a conic projection, and that's where the North Pole is kind of at the top of the diagram, and latitude lines appear kind of curved. So as you move away from the North Pole, the lines kind of appear as concentric cones going down. You can also do a flat projection for the entire world, and that's where latitude lines would appear horizontal going across. And for Alaska, we've got a special conic projection for that as well. So we can just leave this default. It's worth noting that once you establish a map projection, you need to continue using that projection for that given diagram. Different diagrams can have their own projections, but once it's established, it becomes a property of that diagram. So we'll click OK here, and it will, automatically zoom to the extent of the borders that we inserted. So we can see the state of Texas right here. And if I wanted to add counties, I can just repeat that process by going to the auto insert, choose borders. It remembers my selection of Texas. This time we'll choose county, and of course keep the same map projection, and then click OK. And then it draws those counties inside. This next slide describes some more details about those projections. And again, once it's chosen, it needs to be kept. And here's an example with the United States, Mexico, Central American countries, and Canada and its provinces shown using a conic projection. As we can see, the latitude lines are curved with a conic projection. And here's an example with some counties in the United States. And here's an example of an entire world projection using Mercator. So horizontal latitude lines. The next couple of slides describe zooming and panning functions, and these are accessible on the One-Lines ribbon tab. So going back to Simulator here, if I choose One-Lines, I can see there's a zoom group right here, and I can mouse over them to see certain things like, for example, if I want to zoom in on an area, I can choose that, and I get a crosshair pointer, and I can left click and drag to zoom in on an area. You can also zoom in with like a single step per click. So I click on the diagram and it'll center where you click it. You can also zoom out like that. Show full is another quick option, and what it'll do is it'll just zoom so the entire extents of what you've placed on the diagram are visible in that view. You can also use some keyboard shortcuts for zooming. And if you hold down the Control key and use the up arrow, so I've got Control down and I'm pressing the up arrow. Each time I press it, it steps in a small step, or if I hit the down arrow, it'll go back. Continuing to hold the Control key down, I can page up or page down, and it's a similar function except it's taking larger steps each time. You can pan by clicking and dragging, and I want to deselect any zoom functions that might be selected. So I just have a regular mouse pointer, and then I want to click on a part of the background that doesn't have anything on it. And left click, hold the mouse down, and then you can just drag. And that will pan around the one-line diagram. You can also use the arrows without the Control key. So I'm pressing right arrow, left arrow, up and down to pan on the diagram. If you like to use the mouse wheel for zooming, you can go to the Simulator Options dialog, And if I mouse over that here in the quick access toolbar, I can find it. It's also on tools and probably a few other places as well, but it's just called simulator options. If I click on that to open that dialog and I go to the Oneline group here on the left and expand that and then choose visualization, then I can enable mouse wheel zooming. That's right here, this checkbox right here. So it's enabled. If I spin the mouse wheel up or down, it'll zoom in or out. So if you don't like that, you can clear that checkbox and the setting will be saved in the registry. So anytime you're in any PowerWorld case and have a one-line diagram open, that setting will be remembered. So back to the slides, those details are described for zooming, and there's one for panning as well. So next we'll start to add some power system objects to our dialog, and what we'll want to do is use the zoom tools to zoom in on Sterling County. It's okay if you don't get this exact. This is just kind of for demonstration purposes, but we're going to try to lay out the buses roughly where they belong here. So in Simulator, go to my one lines, and I'm going to use the zoom in on area right here. And this is Sterling County right here. And I'll just click and drag, and there we are right there. So next I'll switch to the Draw Ribbon tab and then choose Network and Bus. And there's multiple ways to put buses on a one-line diagram, and we'll go through a few of them here, but this is one right here. I've chosen bus. I come down here and I've got the crosshair mouse pointer, and I can left click then in the dialog and it'll bring up a bus dialog. And the one I want to pick is 3058, which is called Sterling, or yeah, something like that. I'll click, I can just type in the number 3058 and then choose find by number, and it's right here. Or you can use a find dialog right here and type in a number, or choose the name option and start to type in a name, and it'll jump to the next match. So this is the bus I want, and I'll click OK, and it'll add that to the diagram. It's zoomed out to the point where it's a little bit hard to read, but if I zoom in, I'm using the keyboard shortcuts right now to zoom in, arrows and control page up. So there we are right there. And I'll use the same technique to add a few more buses as well. So we'll go to Network, Bus, click in here, and this time I want to type in 3059, and then OK. That's another Sterling bus, Network, Bus, 3060. Okay. And then Network, Bus, one zero 1020. So that's in a neighboring substation, Big Spring. I'll click OK there. And you can do that as many times as you need to. There are other methods that are a little bit easier for adding neighbor buses, and we'll get to that pretty soon. But once you have buses on the one-line diagram, you can rearrange them if you want by left-clicking and holding and then dragging them. So it's distinct from panning. If I click where there's nothing and drag, then I'm panning the entire diagram and I'm not actually moving anything. But if I click on an object, you'll see that the object will have some handles that appear to, and you can do some resizing with that if you want. I can also click the name and kind of reposition it a little bit if I need to, and so on. So next, let's add some transmission lines and transformers to connect these buses. An easy way to do that once you have buses on the one line diagram is the auto insert feature. So this is under Draw, Auto Insert, and I want to choose lines here. And let's clear the option to insert text fields. We'll just clear that checkbox right there and take all the other defaults and click OK. And so what that does is it just draws any transmission lines or transformers that exist between the buses that are on the one line diagram. And I can see I have a couple of transformers right here. If I want to reposition those, I can just click and drag. And the line, this is called anchoring. The line will basically stay anchored to the bus that it's connected to. So, like for example, I could put this guy up here and then maybe Big Spring over here. And then I can kind of see that my transmission lines have come a little disoriented because of the movement I've done. If I want to click on a transmission line, it'll show some handles there, and I can click on an individual vertex to just drag that too if I want to reposition those. So I can do that with the lines and transformers. And so on. I can move the text over here if I need to. So this slide just explains what we just did with buses, and the next one with the automatic insertion of the transmission lines. And we automatically join the buses that were already added. There's an option to include breakers and pie charts, which we did leave checked. So these are the options kind of described right here on this slide. And you can also automatically insert loads, generators, and shunts as well. There's a separate step for that, or you can also do it in a single step by automatically inserting the lines with the generators, loads, and shunts. So that option again is on the draw menu. And we'll go to auto insert. So you have different variants of those. You can just individually do generators, loads, shunts. You can do all of them, and so forth. So we'll just choose the lines, gens, loads, and shunts. And again, you've got some checkboxes to pick certain options. And we can click OK, and then it'll add them. So it drew a capacitor switch shunt here at Big Spring and a generator here at Sterling. So again, if I need to rearrange, you just click and drag. You can resize things too by clicking their handles and moving them like so. Generator. So this slide shows what we did with that. And if you had checked the insert text field, which I did not in my example, it would show these text fields right here for the shunt and for the generators. And this slide describes what we did with repositioning buses. And again, if you're clicking it in the background, not on a specific object, it will just pan on the one line instead of moving the objects. And with transmission lines, when we select a transmission line, in addition to repositioning vertices, we can also create new ones if we want to custom route the transmission line. So if I hold down the control key and click on the line, then it'll add a vertex. And then I can reposition that vertex too, and do that as many times as I want. If I accidentally decide that I really didn't want to create that vertex, I can hold down control and click on one that already exists, and it'll just remove it. Another thing I didn't mention earlier is when you add transmission lines, we auto-inserted transmission lines. You can also insert transmission lines with the network dropdown, kind of like we did with buses. So let's say, for example, this line between Sterling, this one wasn't on the diagram. I can just choose it and then hit delete. And we made reference to this earlier with one-line objects. You can choose whether to delete just the screen representation, just the one-line representation of the object, or the object itself in the underlying PowerFlow. In most cases, you probably just want to delete what's on the one line, but if you actually want to remove the line from the case, then you can choose delete objects and records. But if you want to just delete it from the one line, you choose delete objects only. And then there's an option to always delete objects, so it won't bring up this confirmation dialog again. I like to have the confirmation dialog on because sometimes I might want to take one action or the other, and it's good to have that option. So I'll just choose delete objects only. So what you can also do is go to network transmission line, and you can click on a bus that represents one terminal of a line, and then you can route the line if you want by making additional clicks. One thing you probably don't want to do is click and drag, because if you do that, it'll just put in a whole bunch of vertices and make a very complicated representation of the line. So you probably just want to single click where you want vertices, and when you're ready to terminate the line, you can double click on the second terminal bus, and then that will bring up the dialog for the branch. This just shows the parameters. If you want to edit any of those parameters, you can right now, but if it's a line that already exists in the case, then you probably just want to leave those and then click OK. And you can also use the same methods in the one-line diagram to actually put in other objects too. So if I wanted to put in a parallel transformer between these, I could also just draw another one. And then double click on the second bus. And it's asking, the transmission line is already there. Are you intending to create a new transmission line? And if I'm actually wanting to edit the case, I could choose yes. And what it does is it adds a new line with a circuit ID 2. And it's copying over the parameters from the line that already exists. So that's nice. If you're drawing a line between two buses where the line didn't exist before, then you would be prompted to enter parameters. And certainly I can change them up if I want. If this line has a different reactance than its parallel neighbor, I could edit that right here and choose OK. But so what I've done now is I've actually edited the case by putting in a parallel transformer. And there's also some shortcut keys for moving one-line objects. So if you select an object and then you want to nudge it a little bit, you can use Shift with the arrow keys instead of Control. Control again does the zooming. Shift does moving of one-line objects. And then this again just describes how we can add or remove vertices from a transmission line if we want to modify its routing a little bit. The next slide explains that you can use a drawing grid if you want. It's usually there in the background. It's not a literal grid unless you want to make it such. But it will basically, when you're moving stuff around or when you're drawing stuff, it kind of sets up finite points where you can add stuff or where you can resize stuff. So sometimes that's handy. This just explains that it's on the one-line ribbons tab. And you can optionally snap objects to the grid or not snap them. And you can optionally show the grid explicitly if you want. And this next line just shows if the grid is shown right here, this is display grids. Here it is in the one-line display options. It would show up kind of as it looks like engineering graph paper with a grid in the background. And by default, lines are shown with two circuit breaker symbols, one on either side. They're not really necessarily circuit breakers. It's just an indication, a visual indication that you can use to click on it to open a line or close a line. It normally adds two, but if you want to put other ones on there, you can. This is just back here. I go to Draw, Indication, and I can choose Circuit Breaker, and I can stick one on the middle if I want. Again, it's not really a breaker. It just, if I go over to Run Mode, I can click on those symbols and it'll open the transmission line. And any breaker symbols that occur on a transmission line or transformer just have the effect of opening or closing the entire line. It's not a breaker as you would think of in an operational sense. And you can do something similar with the pie chart symbols as well. If I switch back to edit mode and I go to pie/gauges, I can add a pie chart. And anytime you put a pie chart on a line, it'll show information for that line. So these two pie charts would show the same information. It's just if you need a second visual, it would show. Lines that don't have limits, so if the limits for the transmission line are set to 0, then that's this value right here, the limit A, then a pie chart wouldn't apply and you would not be able to add one there. So there's some slides that describe, again, the features of circuit breakers and pie charts. And next is described a pretty useful feature. If you accidentally make a one-line action that you didn't mean, you can undo it. You can do that from the Draw Ribbon tab, or you can also do it with the Control-Z shortcut. It operates only on the one-line diagram. It does not actually operate on the PowerFlow case. So that's a pretty important distinction. If you accidentally actually delete an object that you didn't mean to delete, your only recourse there would be to go back to the last saved version of the case to reopen it. But with the one-line diagram, you can undo stuff. So, for example, switch to edit mode. Let's assume I accidentally grabbed and drug this line out of place. You could manually reattach it, but it's much easier just to go to the undo. And it'll put it right back where it was before. And how many actions, you can continue to hit the undo as many times as you want, but there may be a finite number of actions that are memorized. And that's a setting in the simulator options menu. If I go back to that, again, I'm mousing over on the quick access toolbar, the simulator options, and I go to the environment page right here. There is a memory limit for one line. So it's defaulted to 50 megabytes. I've never had any occasion to need to change that, but if you want to, you can allocate more memory or less memory to the undo function, and that might limit how many things can be undone. There's certainly large auto insert options that you can do with, if you've got a large one-line diagram with a lot of buses and you auto inserted transmission lines, if you want to undo that because each line, might take up a little bit of memory to undo, you might bump into that limit. But typically, it's used for accidentally dragging stuff like I did there. If you're trying to pan the diagram and you accidentally click on an object, that's a really common use case for needing the undo. So there's some slides that describe that function as well. And another kind of neat feature that goes hand in hand with zooming is line navigation arrows. If you're zoomed in on a particular bus or substation, if you have a diagram that has substations on it, you can be in a situation where the lines kind of go off the edge of the screen. So I'm using the keyboard shortcuts to zoom in really close here on Sterling 2. And I can't see the other end of the line, but there's this little arrow symbol. And if I mouse over that, it tells me that if I click it, if I single click it with the left mouse button, it'll just jump to that neighbor line. And it looks like, oh, the pie charts can get in the way of that too. It looks like that's what's happening here. If I switch to run mode, then I won't be able to accidentally choose the pie chart. And then I can click on that arrow symbol. Now they're still getting in the way. So if I pan so that they're not in the middle of the arrow symbol, or in the middle of the pie chart symbol, then I can click on them. So I guess that's worth noting too. So if it's in the middle of an object and you can't really click on it because that object's there, you might have to do a little bit of panning to get it off. But that'll jump you then to the neighbor bus. So that's kind of a neat feature for navigating. This can happen quite a bit if you've got a very large one-line diagram, but you need to zoom in to see the detail. The neighbor bus might be a ways away, and it's just a really quick way to pan to that neighbor bus. And there's some options related to that you can adjust on the Simulator Options one-line subpage, and there's a little section with the line navigation arrow parameters. Okay, next we'll look at another method of adding buses to a one-line diagram called the bus palette. And this is really handy if you just need to build out a diagram away from some neighbors. You can just put the first bus on the diagram using the method we did before, and then it's really easy to use the bus palette to find the neighbors that are not on the diagram, and you can just click and drag these in. So let's go over to Simulator again. I'm going to zoom out just a little bit so I can see everything that I've added. Make sure that I'm in edit mode. I'd switch to run mode for navigating those lines. And then draw ribbon tab and the palette for buses. And if I click on the buses that are on the diagram are showed on the displayed bus list. If I click on one there, it will take me to other buses that are on there. So, for example, if I'm on Sterling C2, I can see that this Sterling C7, bus number 3111, is an undisplayed neighbor. So if I click and drag that, left click and drag, and then drop it, again, it's a neighbor to C2, so maybe I'll put it up here. Then it'll draw it, and then it'll auto insert the lines right there. And the option to auto insert is under this options button right here. There's some check boxes here. So I'm auto inserting lines, gens, loads, and shunts, anything that applies to a new bus that I drop on there. So yeah, you can pick other buses to add. Let's say from the one that we just added, C7, if I choose that, then I can see its undisplayed neighbors. There's a silver bus, which must be in a different substation. I can click and drag that on there, and you can do that as many times as you need to add other buses. So again, if you, accidentally grab that load there, again, use the undo function. If I click and drag the bus, then it'll reposition the bus. So this next slide just describes what we did by adding some additional buses and then shows some of the options that are available on the bus palette. The next slide just describes that when you're in a one-line diagram, there's some help options that are context sensitive. So if your cursor is over a generator, for example, and you press the F1 key, it'll bring up help for that object. So you can experiment with that. It works for a lot of the objects that you can have on one-line diagrams, and then also in other contexts within simulator, like a dialog, an object dialog, or case information display. So as I mentioned earlier, and as I showed with like adding a parallel transformer in, you can use the one-line diagram editor to actually edit the case. So let's do an example here where we add a new generator, let's say. So first we'll add a bus that generator might sit at, and then we can add the generator, and then we can add a line to connect that generator's bus to the rest of the system. So we'll switch back over to simulator here. I want to close my palette, make sure I'm in edit mode, and then go to network on the draw ribbon, network bus. And then I'll just click out here, let's say near Big Spring in the background. And if you don't have a bus that was active from a case information display or a bus View Oneline or something else, it'll assume that you want to add a new bus. If that's not the case, then of course you could look for an existing bus by typing in a number and choosing find by number, or use the find, or type in a name. But it's assuming that I want to add a new bus, and it's assigning a new number to it, which is like the next unused bus number. And then let's say we want to keep that default number, and let's give it a name. Let's assume that we've got a new wind farm at Big Spring. So we'll call this, Big Spring Wind Farm. And let's assume it's at 34.5 kV, maybe like a collector voltage, wind farm. And then we'll click OK. So it'll add that bus out here. And then next, let's say we want to put a generator there. So we'll go to network, generator, and then we'll click on our new bus. So because I clicked there, it's assuming I want to add a generator at that bus. It's giving it by default generator ID 1. If you've already had a generator there, it might give it a different name, or I'm sorry, a different. And then we can add some parameters to it as are shown in this slide. So let's assume it's got a capability of 200 megawatts. We'll set that for the max. We can choose the current set point, let's say 100 megawatts, and then also provide some reactive power limits of, let's say, plus or minus 100. So we'll go back here. We'll put in a set point of 100, a maximum of 200, minimum megavar, let's say minus 100, and plus 100. And we could also give it a fuel and unit type as well, if we want to assume that it is a wind unit. It's in the renewable group, WND for wind turbine, or I'm sorry, wind for fuel, and then unit type is WT for wind turbine, or you can pick, there's some specific types of wind turbine as well. If we wanted to pick one of those, we could pick one of those and then click OK. So that adds it there. And I can reposition things if I want. And then let's assume we want to put a transformer step up from here to Big Spring. Maybe I want to furthermore kind of move this down here to prepare some room for it. And I can go to network up here, draw ribbon network, and then I'll choose transformer, and I'll click on Big Spring as the from bus, or I'm sorry, Big Spring Wind Farm as the from bus, and then double click on Big Spring. And you need to put in some reactance and resistance parameters, or at least reactance. Let's assume that's 0.08 per unit, and we'll give it a resistance of 0.003 per unit. You can optionally add some limits for it as well. Let's say it's got a limit of 200 MVA to match the generator. And then we'll click OK. And then that'll add the transformer to the diagram and to the case. And back to the slide, this shows what we did with the note, as we mentioned before. Clicking and dragging the mouse when you're drawing a transmission line or a transformer is usually not recommended because it'll put in a whole bunch of segments and vertices. And so here's some parameters. The slide shows a parameter of 300. I think I added 200, but if you wanted to edit that, you could do that as well. That's worth noting. If you right-click on an object on the one-line diagram, you should be able to open an information dialog for that object. So if I wanted to open that, oh, this is actually for the pie chart that I opened. Now, let me cancel that. Right-click on the actual transformer, and then it'll give me a line information dialog for that, and I can edit and change that if I want. So another handy feature is saved views for one-line diagrams. And let's say I want to be able to come back to this spot on the one-line diagram in the future. I can set the parameters, let's say the zoom and the panning, the position, the panning that I want to save the view for, and then go up to the one lines ribbon tab up here and then choose Save View. And if I hit that drop down and then click again on the Save View that shows up below it in the drop down, I can give it a name, and it's going to default to the screen position that you're on right now. You can optionally, if you have contour information, which is discussed in another section, you could save that with the view. Also layers, which we'll talk about in the future. If you had those, you could optionally save the shown or hidden layers as part of the view. What we'll do for now is just click OK. Or I'm sorry, save. And then it's prompting me for a name. So let's just call it, let's say Sterling City. So we can type that in and then click OK, and then click OK again. So it remembers that screen position. So let's say if I zoom out, or I can choose show full and go all the way back out here. And if I want to return to that, I can just choose Sterling City, and it adjusts the zoom and the pan to get right back to where I was when I saved that view. So the slides kind of show that dialog that we just used. And then also, you know, if we show full, we zoom out, and then from any view that we happen to be in, we can always return to that. And you can save multiple views if you want to. So that's pretty handy if there's certain parts of the system on the one-line diagram that you like to view frequently. You don't have to manually return there using the zoom and pan functions. You can just click the saved view. Buses and substations may also be auto-inserted onto a diagram with geographic coordinates if they're available. The PowerWorld Simulator PWB format has long supported this for buses and substations, and the GEEBC file format has added geographic support. Most WEC cases now have at least partial geographic coverage. So back in PowerWorld Simulator, let's zoom out so that we can see the Texas footprint in our system. And then I want to go to the Draw Ribbon tab, making sure I'm still in edit mode. And then I want to go to Auto Insert Buses. You could do substations as well if you have substations. But what we'll choose here on the Auto Insert dialog is to use the longitude and latitude stored with substation records, because that's how it occurs in this case. And we'll keep the map projection. You wouldn't want to change this once you've established the map projection. And we can optionally choose to auto insert transmission lines when finished. So what that means is it'll add the buses to the diagram and then just draw the transmission lines to connect those. We can leave this box checked also that says insert bus only if not already shown on the one line, because we already did add about 4 or 5 buses. So this will just add everything else. And then the same thing with the transmission lines. It'll draw the transmission lines that are not already on the one line diagram. So I'll click OK. And then it'll pop up the dialog for automatic insertion of the transmission lines. You can choose the options that you want for that, and then click OK, and it'll draw the diagram for you. So this is a very handy way to very quickly draw a complete diagram as long as the geographic information is present. And certainly if you don't have the geographic information, you could load it into the case first and then perform this operation. And back on the slides, the features of that auto insert bus dialog are shown here. This is basically what we did to perform the auto insertion. And then if you choose to automatically insert the transmission lines, the dialog for that will pop up later, and you can choose the options that you want there. We can also edit the default drawing values directly from this, and we'll take a look at that tool next. The default drawing values will basically set the properties for transmission lines that will be drawn in the future, and other objects as well. You could set it for transmission lines, buses, substations, and everything else that you could put on a one-line diagram. It's worth noting that the default drawing value settings will affect only the future items that are added to the one line, not things that are already on the one line. There are ways that you can edit the properties of things that are on the one line, but in this dialog, you're just editing settings for what would be added in the future. So if I go back over to PowerWorld Simulator here, from the draw ribbon, I can open default drawing. There's also a button that occurs on the one lines ribbon. This dialog has a series of grids for each display object that can be shown. So background objects are at the top. Those are things like the borders. Those are background objects. You can also add different shapes if you want. So if we wanted to change how buses are displayed, we could go to the display bus right here. And there are settings in this instance for different nominal KV levels. So you can have separate properties if you wish for different nominal KV levels. And you can right click in the field and insert other rows if you want to have additional differences, or you can right click and delete if you want to get rid of one. In this case, the color of all the buses is always black, and it always is filled black. So they all pretty much look the same regardless of the nominal KV, but there is a difference in the size and width. And you could edit those values here if you want, just by typing in a different value. With the colors, you can double click on a color cell and then choose a color. And there's some standard basic color palette right here. You can also choose colors specifically from the full color palette, and then also enter these different hex values, or different decimal values rather, for RGB and hue, saturation, and luminance, and then view the color right there. And there's a display for the bus itself, and then also a tab for field positions. So this is basically saying that for each bus that we insert on the diagram, it's going to show the name field. If it's a horizontal bus, it'll show the name directly to the right, which is what we saw when we were inserting buses manually. We saw that it dropped the name of the bus to the right. If the bus is in the vertical position or vertical orientation, then the name would appear here. And you can add other fields if you want, just by double clicking on this existing one. And let's say we wanted to show the bus per unit voltage beneath it. We could choose that and then click OK in that position and then just say yes. And that adds it there, it adds it here. And again, that'll affect future buses. There are some preset settings that you can invoke if you wish. One is called recommended multi-kV level defaults. And if you check that and then choose yes, it'll overwrite what's in there right now and come up with the scheme. Basically, the scheme that we already used matches that one, but you can change it if you wish. And then there's also recommended single kV level defaults. And what that would do is it would have the same settings for every kV level. So instead of having 6 different rows for these different kV levels in buses, same thing for other objects as well. There's like transmission lines. We can see here different kV levels have different colors, and that's evident on the lines that were auto inserted right here. The 500 kV lines are in this range between 400 and 600. So they get the orange color and they get these properties as well. If you use the single kV defaults, it would get rid of the multiple lines and just replace everything with properties for non-kV above 0. So I can just demonstrate that real quick here. If we click recommended single and click OK, yeah, it just gets rid of all those. Everything would appear black and so forth. So I can change it back going here. If you make your own settings for default drawing values and you wish to save them and not have them be lost when you switch to a different set of settings, then you can save them to an auxiliary file right here. So you can make your edits if you want. If you want to change the sizes of things or the colors or any of the properties, any of the fields that are shown, all of those settings, you click Save All to the auxiliary file, you give it a name, and you click Save, and then you can reload that in the future if you need to go back to those settings, or if you just don't want to lose them after a period of using different settings. And these next couple of slides just show the features of those dialogues. So this is a shot of the transmission line transformer, the characteristics of the lines and transformers themselves, and some of the fields that you can edit for those. And then this is the tab for where fields would show up for transmission lines. And again, you can just double click on any of those and then put in different settings if you want. It's also worth noting that there's like a default font that would govern everything if a specific font isn't selected. So if we come back here, we can see this font size is grayed out right here because it's using the default font. So if you wanted to change that, you could come in here and change it. There's a size and a font style that's used. And then this box is checked down here, which is the reason why this is grayed out. So if I decheck that box, then I could set different font sizes for different levels if I wanted to. And back on the slide for the field position tab, it also notes that if you have a field that is shown at a certain position, you can click on it to bring the dialog back up, and then there's a remove field option at the bottom of that dialog if you just want to take the field off of the default drawing values. And then here's this example of what it looks like when the lines are all auto-inserted and the buses are auto-inserted in the Texas case, as we just did it. PowerWorld Simulator stores cases and one-line diagrams in separate files. The case has the extension PWB, and one-lines have the extension PWD for PowerWorld diagram. Each one-line diagram may be associated with one or more cases, and vice versa. A case can have multiple one-line diagrams. Like for example, you might have a one-line diagram that has buses and lines and transformers on it, and another one that just has substations with lines connecting substations. And you could also have one that has areas and tie line interfaces that connect the areas. Since we've made some changes to our case and we've added the Big Spring wind farm generator, we might want to save it in a different file name so that we still preserve the original base case. So to do that, we could go to the File menu and then choose Save Case, Save Case As right here. And we can give it a name such as ActiveSG 2000. Let's append Big Spring Wind to it. And then click Save. And then the confirmation dialog asks if we want to change the name of the one line to basically match the base file name of the case, but with the PWD extension. We haven't even saved the one line yet, and that's probably a good choice. So we can just say yes to that. And then it will, it may or may not save the file depending on what your settings are. If I open my message log right here, it tells me, because I have a preference for saving the one-line diagrams explicitly with a save command for the one line. You can also set Simulator to automatically save the one-line diagram every time you save the case. I prefer to keep them separate, so this option is set that way, and it tells me in the log that I did not save the one-line file. But if I go to the simulator options, and I'm going to close the message log here, and then I'll mouse over right here to simulator options and open that. And then I'll go to the one line sub tab, and then the file, the one line page and the file sub tab. There's an option down here for saving one lines when you save the case. If you want them to just save together, you can choose always. If you want to decide on a case-by-case basis whether you want the one line saved when you save the case, you can choose prompt dialog. And as I mentioned, I prefer the never option, because I would just want to go out and save the one line when I make changes to it that I want to save, and maybe I'm doing something with the case and I don't want to save the one line separately, so I'll do it explicitly. So what I would do if I needed to make some edits to this one line is come in here and then just say save one line. And because I haven't actually saved it yet, it's given me this file dialog right here. So I'll say save. Once you've saved it once, then you can just go back and say save one line. But again, that's not necessary. If you choose the other option to save it always or to prompt, and then you choose yes, then you wouldn't need to make a separate operation up here in the file menu. Next, we'll take a look at a tool for finding objects on the one line. And this is easily accessed from the local menu, which is what you get when you right-click on the background in a one-line diagram. So in Simulator, I'll just right-click on the background and then choose Find Object on One Line. And you can search from these different object types. Right now, we're looking for a bus, so I'll leave it on buses right here. And then you can sort either the list by number or by name. For example, let's switch it over to name and just start typing Sterling. That's where we started when we added the buses one by one and with the palette. And if I go to 3058 and choose OK, then it'll take me in to that part of the diagram. And this process is also described here on this slide. And when we just did that example, the zoom level changed from showing all of Texas and then kind of zoomed in on the Sterling area. And that's because the auto zoom when panning box was checked there. But you can also uncheck that if you want to keep the same zoom level as you find the object. And back over in Simulator, let's say we wanted to solve the power flow. We could just click the Solve Power Flow button right here on the Quick Access toolbar or on the Tools ribbon. And that'll just do the Newton-Raphson nonlinear power flow solution when you check that. And the resulting power flow solution is shown on the one-line diagram with these flow arrows right here. There's also an option to animate the solution process, and that's with the play button right here. So again, I'm still on the Tools ribbon. It should also be mentioned too that when I went to solve the power flow, it automatically flipped me over to run mode, which is where it needs to be to do the power flow solution. If I click the play button, then what it's doing is just continuously solving the power flow and updating the display. You can interact with the diagram, like for example, clicking on a circuit breaker symbol to open a transmission line. And if the play button is set, it will resolve the power flow with that line out of service and continue to respond to any other changes that you make. I'll put the line back in service here, and it solves it again. When you want to stop the solution and animated process, you can click the stop button, which is located right here next to the play button. If you right click on a specific object, let's say a transmission line, it'll bring up a local menu for that transmission line. And for example, we could open the information dialog for this line that I just right clicked on. And you can interact with the case, modify the parameters if you wish. Most of these dialogues are arranged with different tabs for different fields falling under certain categories. Back on the topic of formatting objects, the default drawing values that we looked at earlier allows you to make a change to the appearance of future display objects. So in other words, objects that you will add to the diagram in the future. If you want to change the appearance of things that are already on the diagram, there's a few tools to do that. And if you want to make the same change to multiple objects, you can make a selection of multiple objects first and then do the formatting. Back in Simulator, if I switch to edit mode, I can click on an object, like say this Sterling C2 bus, hold down the Shift key, and click on other objects. And they can all be buses. If I miss, it'll give me a little signal like that. Or they can be a mixture of objects like buses, generators, lines, and so forth. Another way is to go to the Draw Ribbon tab, and there's a Select Region option, along with some other options that control the select region. So right now I've chosen it, and this tells me that the region is going to be a rectangle, and that to make a selection, the objects have to be inside the rectangle. So I come onto the one-line diagram, and I left click and hold, and then drag. And then when I release, it'll select everything that's inside that rectangle. If I just click on the background, it'll clear the selection. And you can see there's other options too. Like I can make a polygon, and then you can click multiple times to choose your region, and then double click when you want to place the last vertex of the polygon and make the selection. The other option besides inside is touching. And if you use that option, I'll go back to the rectangle here to make it simple. Then objects don't have to be entirely inside the rectangle to be selected. So when I released it, I can see these transformers right here were selected. I can see the handles on those. even though I released the rectangle right here and didn't completely enclose those transformers. Another option is called select by criteria, and this can be useful for something like, let's suppose we wanted to choose all of the 500 kV lines. So I'll zoom back a little bit to make sure we can see at least a few of those in the view. Those are these orange lines right here. And if I choose this select by criteria option, then I get a dialog where I can choose different object types. And then I also have other filters like areas and zones, nominal voltage. So let's choose all display transmission lines. And for some object types, there's a little arrow here. So like, for example, bus fields. If I click on that and choose it, then it'll give me another pane where I can pick just all of the bus fields or just specific bus fields, like just choose the name and the number, for example. But I'll clear that. And in this example, let's just do display transmission lines, and let's do lines at 500 kV. So we could choose a minimum voltage of 500 kV, and there's nothing in this case that's higher than 500 kV, so we can leave this max at the default of 99.99, or if we wanted to be really specific, in case there are higher voltage lines, we can just choose the min and the max to be 500. And there's other ways. If you want to choose certain area numbers, you can enter a range of areas in here, a range of zones. You can also go to the area tab and specifically check certain areas. Same with zones. But I'll just use all areas, all zones, all screen layers. And there's some other checkboxes that allow you to kind of refine what's picked. You can also choose the inverse of what your criteria are. That's like select all except which meets the above criteria. But again, we'll just keep it simple. We're going to pick all the transmission lines that are from 500 kV to 500 kV. And if you want, you can save the set so that you can come back to it later and use it in future selections. So if I wanted to, I could check save as, and then type in a descriptive name like 500 kV lines. So then that's a set I can come back to. You could also, there's also always stored the previous set that you used, even if you didn't name it. You can do that. But if you wanted to have several sets that you wanted to come back to more than once, then naming it is a good way to do that. So when I'm ready, I'll choose OK, select by this criteria. And then I can see on my diagram, there's handles on all of the 500 kV lines. If I zoom out or pan, I can confirm everything that's orange, which is the 500 kV based on my default drawing values, is selected. So to actually make a change to the formatting, I can go up here on the draw ribbon and choose format. And here I can change characteristics of it. Let's say we wanted to change the color. That's here on line fill. I could choose to make them all, let's say, green. This bright green right here, and choose OK. And you can change other characteristics of them too. Like if you want to put them on a different layer, we'll talk about screen layers in just a moment. If you wanted to change the size, that doesn't really apply. Things that don't apply to objects that you've selected will be grayed out. The font, that would apply to fields if you had selected fields. And object field, that's all grayed out because we just have transmission lines selected. So if I wanted to change the thickness, I could do that too. Let's say bump the thickness up to 3 and then choose OK. And then they all change. Another way you can make the selection or make the formatting choice is you can right click on one of the items that's selected and then choose Format Selection. And back to the slides, this one shows the different ways that we can make a multiple selection that we went through. So left clicking on the objects and hold down the Shift key, selecting by the region, rectangle or polygon. There's also an ellipse choice for that, and the select by criteria dialog. So the example we did was changing the color of 500 kV lines, and we did that with the select by criteria dialog after we made, or to make that selection, all the transmission lines, and then you select a range of voltage that applies, and then if you want, you can save the criteria set. And so we changed the color. You can also change thickness. You can also change the characteristics of the line, whether it's dashed or solid. And the second color would apply to things like transformers because they have two different voltage levels, and you can optionally use a second color for those. Another formatting operation that you can do on the one-line diagram, especially with text and with some other objects like background lines sometimes too, is you can resize or rotate them. If you click on a one-line object, then these handles will appear, and the black border boxes you can grab and resize. The gray ones are just kind of placeholders to show you the boundary, but you can't actually click those. And the green circle one you can click and rotate. So if I'm back in Simulator and I zoom in to where there's some text, like some bus fields, for example, I can left click on that, and then these handles will appear. And if I left click and drag, I can resize on the black boundary squares, and the green circle, when the rotation symbol shows up, I can left click and hold and then rotate the angle. And you can also set angles and font size as well in the format menu, of course. If you go to the font right there, you can just change the font size, and you can also change the rotation angle here on the display size. So if I wanted to set that back to 0, I can do that there and change the font size, set the font size there. The next feature we'll talk about is screen layers, and those can be accessed here from the One Lines ribbon tab. They're screen layers. If I hit the drop down right here, I can see a list of layers that are already created. Right now there's just default layer and borders. Default layer will always exist with every one line. When you create a new one line diagram, there'll be a default layer, and there's limited things that you can do with it. You can't turn it off, for example. So the objects that are on the default layer will always be displayed unless there's some other thing that's keeping them from being displayed. If I zoom back here, I can see when I auto-inserted the county and state borders for Texas, that it placed them on a screen layer called borders. And if I hit the drop down on layers and click borders, then it'll clear the checkbox next to it, and all the objects on the border layer will not be visible. So I can restore that just by checking it again. And then if I click the define layers up at the top, it'll open a dialog that will provide more details and more things that you can do with the layers. So again, the default layer is always going to exist. You can't change its name or a lot of its other properties. They're grayed out here. But with borders, we could change the name if we wanted to. We could call it Texas Borders if we wanted to. We can here toggle whether or not it's shown, whether or not it's selectable in edit mode. Sometimes it's useful for things, background objects that you don't want to actually accidentally move. You might want to make those not selectable in edit mode. And if I do that and I come back to my one line diagram, I'll see if I just left click on like the borders, it won't select them and make the handles visible. So there's no way I can accidentally move it if I'm just trying to do something like pan on the screen. So that's kind of useful. If I go back in here, you can also have them be visible, the conditional zoom right here. If I set that to yes, and I could hit say like a low zoom level of say 5%. Make this bigger again. If that's the setting and I close it, I can see right now I'm at a zoom level of about 2.29%. So they'll disappear until I actually zoom down in to at least 5%. So you could use that to put some objects, like say lower voltage transmission lines and buses and other lower voltage objects. You could put those on with a zoom level where they don't appear until you're zoomed down really low, and then when you zoom back, then you don't see them. Of course, with borders, that doesn't really make that much sense. So I might just take the conditional zoom off with that. And like with a lot of other simulator dialogues, we can, if we right click in here, we can choose insert to create a new layer. So let's say we wanted to put everything that is below 100 kV on its own screen layer so that we could have it have different display characteristics. We'll just choose insert, and then we can give it a name, say less than 100 kV, and then just click OK for now. We'll maybe come back and edit some of these other parameters for it. But we've created the layer right now. It doesn't have any objects on it. So the next thing that I would want to do is add some objects to it. And the select by criteria is a useful feature to choose objects to put on layers, especially layers of this nature where we're maybe grouping them by nominal kV layer. We can use a select by criteria to choose objects that are in that nominal kV range. So I'll close this dialog, and then I'll go back to the draw menu and then use select by criteria. And let's say I want to pick everything that's less than or equal to 100 kV. I can choose all object types right here. Check all, and then put in a nominal voltage range of maximum, let's say 99.99 kV, and minimum 0 kV. And then I could save that as, less than 100 kV, and choose OK, and then select by criteria. So it'll go out and pick everything that meets that filter. And then what I could do is I could go to the format dialog, and then on levels/layers on that tab right there, I can assign them all to my new layer less than 100 kV. And you can also add new layers directly from here, or just if you hit this define right here, it'll just open up that dialog. So let's say with the less than 100 kV, I wanted to use the conditional zoom with that, and then have it have a low level zoom of say 5%. So you put the 5 in right there, and then choose close, and then OK on this. Looks like I made a little mistake there and accidentally put my borders on my less than 100 kV level. I didn't really mean to do that. So I could go back into select by criteria right here and just choose the background lines. Let's see, uncheck all, background lines, select by criteria, and I didn't pick them up. Let's try that again. Background lines, select by criteria. There we go. Okay. So I want to change those back to the Texas borders. So those borders are actually just background lines. And so I should have, in my select by criteria, omitted that when I was trying to pick everything that's under 100 kV, because background lines don't really have a kV, but because of that, they're kind of included in any kV level. So they got swept up in that just because I chose to check the box for background lines on select by criteria, which I should have left that unchecked. But anyway, I'll change those back, and then it should behave the way we want. If we zoom in, and I don't know how many lines we have that are below 100 kV, but those should show up with zoom levels that are at least 5% and then go away otherwise. Yeah, because the conditional zoom is set to have them just show up at 5%. So back on the slide here, here's an example in this screenshot here with screen layers for a whole bunch of different nominal kV layers, levels rather, and they can each have different characteristics, and you can also check the boxes on the drop down to show or hide various layers if you want. So that can be a handy way of controlling the display detail on any dimension. It doesn't necessarily have to be kV levels. You can have just different objects on different layers and turn them on and off as you need to. And the next slide just explains again that borders are normally added to a screen layer called borders. But when you auto insert the borders, there's a little section in there where you can change the layer if you want to put it on a different layer. And it also gives the example here where we have a layer called gens, loads, and shunts. And then you could use select by criteria to grab all of the gens, loads, and shunts and then assign them to that screen layer. And this slide just shows some of the other things that you can do on the format dialog on the levels and layers tab. So we already did the thing where we changed the layer that it was on. A couple of other things you can do is that individual objects can basically kind of keep a fixed size between different zoom levels. This might be useful for things like background text or things like that, where you want it to not get too small as you zoom out. For example, you could set a minimum zoom level to resize at a certain level so that when you zoom back out to a higher view, it doesn't get any smaller, or vice versa. Yeah, pie charts and things like are kind of useful for that as well. You can also have things like not move when you pan, or not move at all in terms of their, or not grow or shrink in terms of their size when you zoom. So that's useful if there's like some text, for example, that you want to put in the upper left-hand corner, and you always want it to appear in the upper left-hand corner of the diagram, no matter what, no matter where you're zooming to or panning to in the power system or in the geography, then you can do that. You can fix its location and or fix its size, whichever or both of those that you want to do. As we'll see in a little bit too, you can take objects and change how they appear relative to being on top or underneath other objects. And there's a feature that's similar to what you use in PowerPoint or other graphics programs, where you can send an object to the front or to the back. But then there's also another hierarchy, which we call stack level. And there's 4 of those: top, middle, background, and base. And certain things will by default kind of appear at different levels. Like, for example, a pie chart will always appear on top of a transmission line. And that's because it has by default a higher stack level. And things like background lines, or like borders and things like that, will show up on these lower stack levels by default. But you can change those if you want as well. So that's like kind of the first hierarchy of how things are drawn relative to other objects. And then for objects within given stack levels, you can send them to the front or to the back. So yeah, this next slide just kind of describes that. So different types of objects will have different levels by default, but you can change them if you want to. But usually there's no reason to. Transmission lines will appear in the middle. So circuit breakers will appear on top of transmission lines, but transmission lines will appear on top of stuff that's in the background usually. So the first level of changing how things appear is the stack level, and then the next one is sending it forward or backward within the stack level, and that's shown like on the next slide. So I can switch back to simulator and show that. So in the one line diagram, for example, I can zoom on down, and if I pick a pie chart, for example, and I go to the format dialog for the pie chart, I can see that the stack level that it's on is top. And normally that's a good thing for pie charts, but if I changed it to middle, for example, that should match what the transmission line is on. Yeah, the transmission line here is also on middle. And so if I wanted to now, I could right click on, or rather just click on the pie chart and use one of these other options like send to back or bring to front. So if I send it to the back, then the transmission line would draw on top of it. Again, normally you wouldn't want to do that, but you can if you wish to, you can do that. So if I change the stack level of the pie chart back to top, then it's going to draw on top. And even if I send it to the back up here, it's not going to go behind the transmission line because the transmission line is on a lower stack level. So usually you don't have to change that sort of stuff, but it's good to be aware of it in case you want to change how things appear. And if you're trying to send something to the back and it's not going all the way to the back, it's probably because there's something behind it still that is on a lower stack level. So just be aware of that. So if I select, for example, a bus right here and go back to the format menu, we can then look at the next tab over, the display size. So with some things like with buses, you can resize them just by dragging the handles. You can also resize them here if I want to change the size from say 5 to 10 and the width from 0.2 to 1. And then I click OK, it'll draw itself bigger like that. So if I go back in there, there's also an orientation feature that applies to some objects like generators and buses. So right means that the bus is drawn to the right from its origin point. If I change that, I can change it to up or down, and that'll make it go vertical. So if I click OK on that, then yeah, it's going up and down. Some additional formatting things you can do with text fields is if I open the format dialog again, over on the right two tabs are font and field. So with font, again, you can change the size. We kind of looked at that a little bit earlier. You can change the font. You can make it bold, underline, kind of typical things that you might see in word processing or presentation software. Change the font color. And on the field tab right here, you can also change, if it's an object field, you can change the field from, like right now it's the name of the bus. I could change it to the name and nominal KV if I want. If it's a numeric field, you can edit the number of digits. You can also put a prefix in it if you want, like name / num kv, something like that. Some fields have suffixes, like the megawatt output of a generator or a load. The suffix would just be MW, and so forth. So then I can click OK on that if I want. And I can see that the changes were made right there. If I zoom in, of course I didn't change the size of it, but I can see it changed the field and added the prefix that I put in there. Another thing you can do is apply default drawing values to objects. And we looked at this a little bit earlier with the transmission lines that we changed color of, but if we select an object like this bus and we right click on it, we can choose to apply default draw values to a bus. And of course, this applies to multiple objects like it did earlier with the transmission lines. And then you can pick which attributes you want to apply from the default draw values. And it'll take that bus back to the original thickness. Now, it doesn't change the orientation. So if you wanted to make that horizontal again, you'd have to go and make it horizontal. Once I changed it to vertical, that's going to stick. But another kind of related thing I can do, if we notice that with this bus being vertical, the transmission lines no longer like come into it properly. They're just kind of floating off here in space. And I could use a tool that's under the auto insert menu called reset the stub locations right here. So usually it makes sense to just select a few buses, one bus or a few buses. If you do it for the whole case, it can kind of take some time. But I can see here in the dialog, it gives me the option to use only the selected buses or substations. This works with substation objects also. And then I can click OK on that, and it'll bring the transmission lines into the bus with the vertical orientation there. So the slides show some of those features that we just talked about, like on the formatting objects. This one shows the features of the display size. And then the font tab also for text fields. And the field one. And then especially for object fields, you've got these things enabled right here where you can change the field. And again, if it's numeric, you can change the numeric characteristics, optionally add a prefix, and include the suffix for fields that use suffixes. And then here's with the default draw values like we did with that bus. So we applied the default draw values to the selected objects. And of course, that again works with a single object selected or with a multiple selection. And then the reset stub locations, we demonstrated that with the bus with the changed orientation. It's kind of useful for that. It could be useful for other circumstances too, in which maybe you've rearranged some transmission lines and the stubs of the line doesn't come into the bus or the substation the way that you want it to. And then there's a few other information only slides in here with the red dot that just kind of explains with the select by criteria. If you're picking fields, you can specify only a certain subset of fields or all the fields. If it's all the fields, then these little check boxes underneath it are grayed out. If you change that to specified, then you'd have the option to check or decheck these individual classes of fields. And that's going to apply to any of the field objects. Like this is a substation example, shunts, loads, generators, whatever types of fields that are present on the diagram, you'd have the option of doing only certain kinds of fields if you needed to on your select by criteria. And then you can also, this is again on the select by criteria dialog, you can filter by area, zone, or screen layer. On the screen layer one, it'll show you all the layers that you've created, plus the default layer. and you can pick objects that are only on selected layers if you want. And you can also use advanced filters with a lot of different objects. So if there's a set of dashes in this filter column right here, you can double click on that, and then you can make an advanced filter on the fly, or you can pick from one that's already been created. We talk more about advanced filters in a different training topic. The I3 topic is where to go to learn more about those. And there's also these eyedropper and paintbrush on the formatting section of the ribbon there. Works similarly to how it does like in presentation software, where you can select an object that has the source formatting and then click the eyedropper and then select some other objects that you want to receive that formatting and then click the paintbrush to put across it. And just a note about that is if you've got a multiple object selection that you're using for the source, and some of the attributes are different in different objects in that selection, then it won't copy those attributes. But it often works best if the source is just a single object. And then again, you can select the destination objects and then hit the paintbrush, and then it'll bring up a dialog like this, which is asking you which attributes do you want to copy from the source object. And you can check all of them that are not grayed out if you want, select all or unselect all. And then when you have the selection you want, you can click OK to paste those attributes on. And there's also a function to delete objects from the one line, and it's got a few different options with it, because you can use the one line, of course, as a case editor. If you add an object to a one line, as we did earlier with the Big Spring wind area, it'll add those objects to the case. When you delete objects, it gives you the option of just deleting the one line diagram objects, or actually deleting the objects from the case. So let's say, for example, we'll go back to our Big Spring area and delete the shunt object. So back in Simulator here, I can go to the One Lines ribbon, and then in my Save View, go to Sterling City right here. And let's say I choose this object, and this works for a multiple selection too. So again, you can hold down the Shift key and pick multiple objects. You can use the Select by Criteria or select a region, that sort of thing. But if you hit now the Delete key on the keyboard, or the Delete up here on the Draw ribbon, then it'll ask you if you want to delete the object only, meaning the screen object, or do you want to delete the object and the underlying power system record as well. Normally, I like to just delete objects only from the one line diagram, but if you're using the one line diagram to edit the case, then you might want to delete the objects and the records. And then this third option in the middle here, you can tell it to always delete the objects, and it'll save that as an environment variable so that it won't give you this confirmation dialog in the future. But let's say I just delete the objects only, the screen object will go away. But if, for example, if I go to the bus view for Big Spring, I can see that the shunt is still there, and I can right click on it and see it's still in the case. It's still got the parameters that we set for it earlier. And yeah, it's still there in the case. It's just not on that one line diagram. The next few slides describe some of the object fields that are available. And there's others that aren't described on the slides, but they work pretty much similarly. But when we auto inserted the buses earlier, it automatically put the bus name next to each bus. And the reason it did that is because that was specified in our default drawing values. You can also manually add a field from the Draw Ribbon tab, or you can also make a selection of a single object or multiple objects and then right click and choose Add New Fields Around Selection. So we'll look at the ways of doing that next. And so back in Simulator, I'll go ahead and close this bus view one line. And let's say I wanted to put the per unit voltage of this big spring bus right next to it. One way I could do that is go to the Draw ribbon right here and then choose Field. And there's a whole bunch of different object fields. We're not going to go through examples of each one, but we'll talk about a few of them here. So bus field, we'll just click that. They all kind of work the same way too. So if you know how to insert a bus field, you know how to insert a load field or a generator field or so forth. So when you have the crosshair here, you can click on the diagram and then it will figure out which bus you clicked closest to and put that up there. If you needed to change that, you can change a different bus to a different bus as well, but it's going to pick the one that you go closest to. And then some of the more common fields are just shown right here on the dialog. So bus voltage per unit is what I talked about adding. And so that'll be shown right there. If you want to use a different field, one of the others that aren't one of these more common ones, you can click on Find Field and it'll open another dialog and give you access to all of the possible bus fields. Right there, you can change the number of digits that are displayed and then just click OK. And it'll put it, on there. You can rearrange it if you need to. But that's one way to do it. Another way to do it is you can make a multiple selection. Let's say we use the select by criteria to pick all of the buses. So we'll do that. Select by criteria right here. It's remembering my last selection set. I'll just choose uncheck all. We'll do all voltages, all layers, all zones, and then just pick display bus. And then choose select those. So it picks all the buses on the diagram. And then I can right click on any one of the buses that's selected and then choose the option to add new fields around the selection. And then it gives you a dialog with kind of placeholders for different positions around the object. So it's a bus. It's showing if the bus is vertically oriented, like the one that we edited to be vertical. The positions 1 through 8 are shown like that. If it's horizontal, it's shown like this. So let's say, for example, we wanted to put the angle of the bus in position 5. So we'll just click on position 5 and then choose the bus angle in degrees right here and then choose OK. It adds it right here. Again, this isn't changing our default drawing values or anything like that, but of course there's a similar dialog within the default draw values if you wanted the angle to show up in any new bus that you add going forward. This will just add it to the buses that are already on there. So I'll click OK, and then we can see that it did that operation. It put the bus angle with the number of digits that were specified on the dialog, and it also put the suffix in, which is the DEG for degrees. So, and that's shown for all the buses in basically the same place where position 5 is located on the bus. Okay, so back on the slide, these are the things that we did. We added the field from the draw ribbon for the per unit voltage at Big Spring, and then we also used the option to add new fields around the selection for the angle with all the buses. The next slide just talks about line fields. That's another option from the draw ribbon. I'm not going to go through a detailed example like that as I did with buses, but it's done the same way. Basically, you can click on the diagram next to a line. There is one key difference, I guess, for things like lines and interfaces, and that is the field is going to be associated with one end of the transmission line or the transformer, because a lot of fields could have different values. Like flows are going to change because of losses. Angles might be different on one end or the other. So it's going to detect, like it does with picking which bus you're trying to get to, based on where you click, it's going to choose an end for you. And DC lines are kind of the same way. I mentioned lines and interfaces, but that's some of those properties. If you just right click on an empty portion of a one line diagram, it'll bring up a local menu for the diagram itself. Instead of, like, if you right click on a specific object, it'll give you a context sensitive local menu for that object. But just going in a blank space will bring up things like one line options. So back in Simulator, I can see that if I just, again, right click on a blank space, I can do things like find specific objects, find a certain text, one line options. You can print the one line, you can copy the image to the clipboard, send it to like a JPEG or a PNG file. So stuff like that. I mentioned the options, the one line display options. So if we choose that, it'll bring up this dialog that has a lot of different pages and tabs. It's kind of similar to the simulator options, which deals with the case itself, but it deals with characteristics of the one-line diagram. So there's a page for animated flows. You can change their characteristics. Pages for the display objects, the display options itself. So we'll talk about some of these things in here as well in a moment. So some of this stuff you actually have to be in run mode in order for it to work. So I'm going to hit cancel for now, and we'll come back to this in just a moment. But we'll talk about some of the options here on the slide. So again, you right click on an empty portion, and you can do stuff like print, save to a graphic file, and so forth. Find objects, we mentioned that. Pan and zoom control. Display options, that's the one that we'll kind of talk about in detail next. Screen layers, and just various other context sensitive options with the one line diagram. So difference flows, that's talked about in a later section. Flow visualization, so that has to do with the arrows. They can show actual flow or power transfer distribution factors. That's covered in a different section in greater detail. And so a lot of the same things that you can get also from different places on the ribbons. So either the draw ribbon or the one line ribbon. So yeah, here's the display options. So I'm going to switch to run mode so that I can see some of these other things like the display detail here. So back in Simulator, I'll switch to run mode, and I can see the arrows come back. And then I'll right click and I'll go to the one line display options again. And this dialog is organized with a lot of categories or pages over here on the left side. And it'll normally open to the one called display options, which is what we're on right here. But there are other pages for animated flows, display object options, geography and coordinates, which we looked at a little bit earlier with the map projections, and other ones here that are described in more detail on the slides. But back to the display options, I want to discuss this feature up here in the upper left first. It's called display detail. Normally it says it's set to complete, but you can change it to different levels of detail. Moderate and minimal are some preset levels of detail, and there's more information in the help as far as what's included on there. The one I find myself using most often, besides complete, is the custom one. And if you choose that, what it'll allow you to do, if you then click set, is to use a select by criteria set. It's the same sets that are available to you like what we did earlier when we were picking certain objects on the one line diagram. So for example, we had the set for 500 kV lines that we used. We could apply that here, or we can build another set of options right here. Let's say instead of just the 500 kV lines, we wanted to show everything above a certain kV level. So one way we could do that is just to pick all types of drawing objects right here. I could say select all, and then over here on the right, I could filter by nominal voltage level. So let's say we want to show 100 kV and above. So we could put 100 down here. We might optionally, if we have lines that are above 500 kV, we might optionally put in kind of a large dummy number like 99.99 to just make sure we catch everything on the upper end. And then we could say, show only these. And when you get back to the original dialog right here, if you want to apply the changes, you can click the apply button. That will leave the dialog open, so you can kind of see what it will look like. And if you like what it looks like and you don't want to make any further changes, then you can click OK. OK will also apply the changes, but it'll close the dialog also. So if I zoom back, I can see it's just showing me everything that meets that filter, basically, which is everything that's at 100 kV and above. So if I wanted to undo that, I could just come back into the one-line display options and then choose the complete detail and then apply. So back to the slides. There's a slide or two that describes each one of these option category pages. We're not going to go through every single menu item that's on here, but the slides go into a little bit more detail, and then you can always hit the help button if you need help on other stuff. A closely related feature to the display detail is the emphasis filter, and that's covered in a contouring and advanced visualization training topic, I6. But basically, what that will do is it's similar in that you can have a select by criteria set, but instead of making the unselected stuff disappear, it just kind of fades it into the background. You can do other things on here like change the background color, change how the fields for transmission line flows, whether they have a negative sign in them or whether they just show the absolute value. So there's a sign convention where positive flows are usually coming out of a bus. So if you just want to show the absolute value, then there's an option for that. Options for out of service elements and several other things. Going up to the page above display options is called display object options. And the slide here shows several things that can be done there, like putting a field inside a generator, where to show circuit breaker symbols and whether to show them on loads generators or switch shunts. Usually you probably wouldn't want to change some of these things, but maybe if your diagram is getting a little cluttered, you can hide the display breakers or whatever. There's options for the generator rotor. So when you hit the play button, when you're animating the simulation, you can have the rotor move and rotate as the simulation's playing. A value of 0 will just keep the rotor stationary at all times. There's options on what to show for transformer symbols. So you can have coils or circles. Normally we show coils, but if you like to see circles for the different sides of the transformer, then you can do that. Also some options for showing how multi-section line buses are shown, intermediate buses. Next to the general options, there's kind of a sub-tab in there for circuit breakers. So you can change how colors and shapes are used for the circuit breakers. So normally they're squares or rectangles, and they've got red, solid red for a closed breaker, and open green for an open breaker. But if you want to change those, then you can. You can change the colors and whether or not fill is used, and then the shape. This next slide just elaborates on the display detail. Again, this was on that first page, and I went through the example with showing just 100 kV and above objects for the custom display detail. Okay, the next category we'll take a look at is the pie charts and gauges, and flipping back over to Simulator to demonstrate that. We can go to that page, and then we can see, first of all, there's just this kind of high-level option. Do you want to show the pie charts and gauges at all in run mode? And if I decheck that and hit apply, we'll see all these little pie charts will disappear. If you want to show them, then you can set different parameters for them. So we just have transmission lines on here, but you can also, if you have interfaces on your diagram, you can set different parameters for your interfaces. But some of the kind of key things about them is you can show what the pie chart shows. So what's selected here is to use amp limits if amp limits apply for lines, or actually it'll just show the amp limit and the percentage of the amp limit. There's whether or not it applies is something that's set in the limit monitoring settings, and it may be different than what's shown on the pie chart. But if you wanted that to just show the MVA, then you could put that. The transformer MVA means, as we'll see more in the limit monitoring topic, transformers are always limited by MVA because the amperage on the high side and the low side is going to be different because of the turns ratio and so forth. But if you just want to show MVA for everything, you can do that. Or if you want to show megawatts, you can do that. Gauges, we're not going to go into detail about gauges, but you can have different sets if there's gauges. Gauges are another indicator that are similar to pie charts, but slightly different style. So you can change what's shown there. And then these features down here pertain to what color the pie chart is, and if it changes size and color at certain percentage levels. So the best thing to do with this, as with a lot of other parameters on here, is to just kind of play with the values and get it to the way you like. So if you want to make the pie charts bigger, you can individually, of course, size different pie charts with the formatting dialog like we looked at earlier. But if you want to apply a scaling factor then to all the pie charts, you could put it in here. So let's just, if we change that to 2, for example, and then we hit apply, then all the pie charts everywhere will get 2 times bigger than what they were before. I'm going to zoom in on a particular area of the dialog and then come back to this so we can see in greater detail like what's being done. And I'm going to go into an area, let's see, where we've got, I'll tell you what, we can just play with the parameters. I was going to go into area that has a warning value, but we can just adjust the parameters so that we can see what that does. So if I go back into the display column options, or I'm sorry, the one-line display options. So right-clicking to get the local menu, and we'll go back to pie charts and gauges. I should also note that there's a different tab here for different types of pie chart styles. So there's an MVA one. I switched this up here to show megawatt pie charts. But if I go to the megawatt tab, it's going to usually default to copying the same settings from the MVA tab. So as long as you want all your pie charts to kind of have the same characteristics, you don't have to worry about these other tabs. But if you decheck one of these boxes, then of course you can have different parameters for different styles. But we'll just keep it simple and just assume we want one set of parameters regardless of what the pie chart style is. The show value percent is the level at which the percent will be shown inside the pie chart. So if I drop that from 80 to say 20 and then hit apply, what I'll see is the number will show up inside the pie chart for any value that's above that level. And let's zoom in just a little bit further too. I can see on this pie chart right here that the value is shown. It's at 31%. It also shows that it's a megawatt value. So that's the MW down there. The A at the top refers to the limit monitoring setting that applies. And again, limit monitoring settings are described a little bit more in a different section, but that's what that's a reference to. So if I come back in here and go back to the pie charts and gauges, right here, it's showing at what percent does the color and the scalar change. And you can right click and insert multiple levels if you want to, but this just defaults to at 80%, it's going to get 1.5 times bigger and it's going to be orange. And if I drop that percentage to say 50 and then hit apply, then anything in there that's at least 50 is going to show orange. This is kind of a unique situation because the scalar here is lower than the normal scalar, which I edited before. So normally you'd want this to be larger, but again, it's fully customizable. So if I put in a scalar of 3, for example, and then hit apply, I can see all the pie charts get bigger by that factor. And then the warning color is kind of this next level where it goes to red, and you can change that if you want. It defaults to 100%. If we made it something lower, like let's say we put this one at 40% and this one at 50%, then we'll see some examples here, and maybe put the scalar at 5. We'll see some examples in this view right here of those values changing accordingly. So, and again, if you want to change the color, you can just double click in there and pick a different color. You can right click in here and insert another level, or you can delete one. I think most users just kind of keep the defaults on this, but it's good to know that it's customizable, especially if you're trying to produce a presentation graphic or something from a one-line diagram and you want to be able to see different thresholds. So I'll just change this back to the way it was before with a value of 80. Oh, and if you change the value and it changes the sort order, then stuff might kind of jump around a little because it's going to sort by percent. So I just typed in 100 right there. That returned it to the original order. And then I'll click OK. So back to the slide for the pie charts and gauges category or page. It shows a little bit more detail, but we certainly covered the highlights as far as like what style you select and then how you change the size and the colors and things like that based on the parameter of what's shown in the pie chart. And this next slide again just shows that for different styles of pie chart, you can have different parameters, or you can just have them follow what is shown on the MVA screen. And then the tab all the way on the left is called Open Parameters, and that just has some options for formatting how open transmission lines are shown. So like, for example, normally there's an X that's shown over the pie chart. If you don't like that, you can change that option. And there's some other related options you can show. But if we go back to Simulator And for example, we open a transmission line, then we'll see that behavior shown in the pie chart where it's green and it's got an X through it. So again, you can customize that if you want. I think most users just kind of leave the defaults for that. And this next slide just describes if we navigate over from pie charts and gauges, there's a tab called General Options, and some of those options are just described here on the slide. This next slide just describes that for the pie chart options and for several other options, if you don't want to go into the dialog and you prefer just to like grab some of these options off of the menu ribbon, you can do that. So let's switch back over to Simulator. I'll show you where that is. So here we're on the One Lines ribbon. And if I go to the options right here, there's one for pie charts. So you can change a lot of those parameters right here. I tend to like to go into the dialog for stuff like that, but if you want to just make some changes without going into the dialog and seeing how they impact the way the diagram looks, then you can do that from here. There's several other categories, animated flows you can access from here, and some other things that are related to the one-line options. And you can also open the one-line options dialog from here, just like we did it earlier by right-clicking and bringing up the local menu. You can also open it from here. And this next slide just shows on the smaller 7-bus case, or a diagram for the smaller 7-bus case, what some of the parameters are and how they impact the way the pie charts are shown. So the colors, the normal scalar, the normal color, the show value %, and different thresholds at which the color changes, and then possibly the scalar changes as well, depending on what you have set. And the next slide describes the category for animated flows. That's the one that's at the top on the left. And what I like to do with this typically, as far as like sizing the way the arrows look, is starting with this button that just says set the size, density, and reference values for this one line. It's basically just going to come up with kind of a guess of what looks good based on the data that's in the case and what you can see on the one line. And then you can just kind of change the parameters to make it fit the way you want. And I like to keep the dialog open and then just hit the apply button as I make changes until I've got it the way I want it to look. So if we switch back over to Simulator, we can open that dialog and do an example. So again, the animated flows up here on the top. I guess it's worth noting the first thing is like whether or not float symbols are even shown. If you decheck that, then a lot of these other things will get grayed out. If I hit apply, it'll take off all the arrows. If I show the arrows and apply, then they're back on. So I guess first of all, you can pick like what's actually shown. Normally we show megawatts with it, but if you want to show reactive power or arrows for both reactive and real power shown on top of each other, you can kind of do that. Here the colors are different. The fill colors are for each category are shown down here. You can change those by clicking on a color and changing it. So the megawatts are shown in green. The megavars are shown in blue. I can see on this particular line, they're actually going in different directions, which can happen. But I think it's simplest usually to just kind of look at megawatts. But if you want to look at different things, PTDFs or geomagnetic induced current, you can switch it to that. But of course, you have to do a calculation for PTDF or for geomagnetic induced current in order for that to make sense. Those are covered in other topics as well. But if I kind of initialize this with the set size, density, and reference values, it'll make some changes to the size and density, and then I can hit apply. I don't necessarily like the way this looks at this zoom level, but you can change that if you want. So size, is just a indicator of how big the arrows are shown. If I want to make it smaller, I can just put in a smaller number. And again, what I kind of like to do is just experiment with it and then set. Density, the higher the density is, the more arrows will be shown per length of line. So I can just kind of change that and hit apply. If that looks too dense, you can kind of back it off a little bit until you get it the way that you like it. You can also have the reference values are just based on like what value of flow corresponds to the largest arrow size. So if you make this number smaller, then more lines will hit that threshold and they'll all kind of appear the same size. So we can kind of change that back. So now it's more proportional. So the size is scaled based on the flow. And then if you're animating, you can also have it scale the speed of the flow. If you hit the play button, lines with more flow will move faster. You can also hit a zoom level for rescaling the size. If you put a lower value in for that, then as you zoom out, the arrows will quit getting smaller as you zoom out past that level. So for example, if I put in like 10% and I hit apply, of course it kind of changes everything here. But if I hit OK, I can see if I check my zoom level right now, okay, I'm at 50%. So maybe 10 wasn't the wisest choice for that. But if I zoom into higher levels, they're gonna kind of stay the same size. And if I zoom back, so once I cross over 10, then they'll get smaller again. Once I get inside of 10, then they'll just basically appear the same size. And back to the slide here, you can also change the symbol from an arrow to other kinds of stuff, although I think arrows usually work best. You can also, if you're hitting the play button and animating the solution, you can have the arrows just kind of scale faster or slower across everything on the display. The next slide just kind of describes how the size and the density affect the arrows. And again, I find it helpful just to change the values, either up or down in order to get it the way I look. It's kind of hard to visualize what this math actually means, but it basically, the flow reference was a parameter on there also. So if you change the flow reference, then it'll change the size of the arrow, everything else being equal. If you change the size scalar, same thing. So, and the spacing, the density affects the spacing between arrows. If you increase the density, then there'll be more arrows on a given length of line on the display, and vice versa if you move it in the other direction. And the next slide just illustrates some of those parameters with a graphic from the 7-bus case. The reference size set to 200. These flows coming out of this generator and into the load that are R200, the size will correspond to that value. Anything smaller will be scaled down, and the size being animated means that the size of the arrow will vary based on the flow. If the animated size if that box is unchecked, then all arrows would appear to be the same size regardless of the flow. And a lot of these parameters, again, can be accessed from the options menu if you prefer to use that instead of the dialog. The next slide describes the thumbnail view. And the next slide shows an example with it in the upper right and the background being yellow. And some of these parameters, again, can be changed from the options ribbon and then the thumbnail drop down if you don't want to go back into the dialog. And the next several slides just show some other things that can be added from the Draw ribbon tab, like for example, background text. The text that we've looked at before have all been like object fields, like we looked at, bus names and bus per unit voltage and bus angles and stuff. So you can put object fields on. You can also just put in background text that can say anything you want, like Texas case or something like that. And then you can format its appearance just like you can with any other object. So these slides are just kind of provided for information only. You can put in some hyperlinks to another one-line diagram or to just an internet URL. You can drop those in. You can add background lines. So things that we added, like the state backgrounds and the county backgrounds, those are just background lines, but they're kind of preset parameters. You can also just kind of freehand draw your own line if you want. And again, if we switch back over to Simulator, these things are found on the Draw ribbon. And again, you have to be in edit mode in order to add those sorts of things. But here under background, we can see we've got text. Memo text just allows you to put in more stuff. One-line links, documented links, background pictures like a JPEG or PNG file, freehand background lines, rectangles, ellipses, things like that. So the slides demonstrate some of those things, like here's just a freehand background line that's looks like it represents kind of a lake. So again, if you want to add stuff like that to your one line, you can. And then also things like bitmap, JPEG, metafile, and I think we now support PNG as well. It just kind of describes how to do it. You click where you want it, and then you go point to the file that you want to insert. And here's an example with some JPEG or other graphic files that are just kind of added as background objects. As we mentioned early in the presentation, you can have a one-line diagram that works with multiple cases, and a case can also have multiple one-line diagrams associated with it. But then there's a question of how can you maintain your one-line diagram over time as you work with newer cases. So for example, say you've created a detailed one-line diagram that works with the current case. And then the following year, a new power system case is issued, but the topology differences means that the bus numbers don't match. Unfortunately, this is a situation that occurs pretty commonly with bus branch models. Kind of a holistic solution is to use node breaker models that don't depend on bus numbers, but rather depend on some other static key, like, for example, that comes out of an EMS. But even with that, the reality is such that people often have to work with bus branch models where the topology does change. So a couple different procedures are outlined on the following slides. One is just to take, the first thing you can do is just take stock of how many elements have changed. And what we call that is if there's an object on the one-line diagram that doesn't line up with anything in the case, we call it an unlinked display object. And this describes how you can view those, a list of those in Simulator. So the one line that we've been building with this case doesn't have any, but we could create a simple situation whereby we have some unlinked elements. So for example, let me zoom into part of this diagram right here. Make sure that I'm in edit mode. And I'll just click on this bus right here and hit the delete key. And when it asks, I'll say, let's delete the objects and the records. And what that effectively did was it removed that bus from the PowerFlow case, and also all the objects that either were attached to that bus or are incident to that bus, like transmission lines. So the next thing I'm going to do is I'm going to close this one-line diagram without saving it. And when it asks if I want to save the one-line file, I'll just say no. And then I'll go to File, Open One Line, and just reopen the active SJ2000 Big Spring Wind that we created. And if I zoom out and then pan down to where I was before, I'll see there's this magenta highlighting that are on those objects. That's the bus in the transmission line that's still on the one-line diagram, but it doesn't have any match to anything that's in the case. So I can get a tabular list of those elements from the one-line diagram if I go to the one-lines ribbon and then go to List Display and then choose Unlinked Display Objects. And what this does is it opens up a view into what we call the Display Explorer, but it's a kind of a filtered view and in a slightly altered view. It just shows the things that are unlinked. So I can see one of them is a bus, which is the one that I specifically chose to delete, and then everything connected to that bus, and then also some pie charts, some text fields, some circuit breakers, things like that are associated with the lines. So if I wanted to clean up this one-line diagram, and this was the only changes that needed to be made, I could click this button up here that says Delete Unlinked Objects. And the confirmation dialog will ask me if I really want to do that. And I'll choose yes. And then when I close this and return to the one-line diagram, I can see that the unlinked objects that were highlighted in magenta are now just gone. So my one-line diagram, again, matches what's in my case. So you could also have a situation where there are things in your new case that don't exist on your one-line diagram. So you could start the procedure by just getting rid of all the unlinked objects like we just did, and then cleaning up the one-line diagram by adding the objects that need to be added. And of course, as we discussed earlier, there's lots of ways you can do that. You can use the bus palette or the substation palette. If there's geographic coordinates and your one-line diagram is laid out geographically, you can auto-insert by latitude and longitude. And you can also just go to the draw menu and start adding objects. And if there's just a few changes, that's probably the way to go. There are a couple of other approaches too. You can open a one-line diagram based on what we call the secondary key. So the primary key fields for objects like buses are basically, for buses, it's the bus number. For a lot of other objects, the bus number is part of the key field. Like, for example, with generators, it's the bus number and the generator ID that are the key fields for that generator. And the key fields are the fields that uniquely identify that object. So again, with buses, it's usually the number if it's a bus branch model. You can also use the name and nominal KV, which is what we call the secondary key. Now, it's not perfect because the case allows you to have more than one bus that has the same combination of bus name and nominal KV. There's nothing in the model that prevents you from doing that. There's nothing in other softwares like PSSE or PSLF that prevents you from doing that. So it's a little bit of an imperfect method. It's a little bit of a heuristic. And it also just may not match up. The same name nom-KV might not be present because maybe the name changed, or maybe even the nominal KV changed. And it also just the bus may still not exist in the next case. So there's some cautions listed on the slide associated with this, but if you want to try it, I'll flip over to Simulator and show you where that. You go up here to the File menu and you go to Open One Line, and instead of just clicking directly, you can mouse over to the right and you can open it by name and nominal KV, or you can also open it by another alternate key field called label. And typically those are going to be populated for EMS models, node breaker models that have a different key field system where the bus numbers are going to change from one model to the next, but the label should be static. And so if you have cases like that, you can use the label field. But with most bus branch models, you're either going to have to open it by the number or by name nom-KV. So the next few slides show yet another method, and that is you can create a swap list where you have a list of all the bus numbers that used to be used, and then you can designate new numbers basically to swap into. And you can use this to change the one-line diagram or the case or both. This can be kind of a tricky process though, because again, it's going to have to initially rely on name and nominal KV to try to do the matching, or you're just going to have to like manually go through bus by bus to do the matching. And at some level, you're going to kind of want to review what's in there. So if you don't have like a good external method to say that here's the new bus number that used to correspond to that bus number, then it's still a very imperfect process. But the slides show you where to go in Simulator. From the Tools ribbon, you go to the Renumber section. That's a drop down, and then you hit Renumber Buses. And then there's a dialog on there where you can set up what you want to renumber and then choose a new number. And then there's a checkbox for actually swapping as well. You can save what's in there to an auxiliary file and then load it up into a new case. So again, this can be a very imperfect process, but in some cases it might be better than nothing. In other cases, you might be best off just to get rid of everything on the one-line diagram that doesn't link to your new case, and then just add the new objects. And again, after you have both lists, then it will have a swap field that you can set. So I'll just briefly bounce over to Simulator and show where this is. So you go up here to Tools ribbon, and then Renumber, and Renumber Buses. So here's the dialog right here. You can pick everything on the case, everything that meets an area zone filter, just the things on the one-line diagram, whichever option makes sense. Click Setup Swap. You can put new numbers in here, and then toggle the swap fields to yes for the ones that you want to swap. And you can save this to an auxiliary file as described in the slides if needed, and then open a new case, and then open the one line or load the swap information in. It'll automatically populate the new number based on name and nominal KV matches. You can check that list and then do the swap. And when everything is set up and ready to swap, then you would click change bus numbers. Oh, and before you do that, you can choose to change only the numbers on the one line, or only the case, or in both. But if you simply want to relink from an old one line to a new case, then you could just change the one line diagram.
Then after you do that, you should be able to save the one-line diagram. I would save it in a new name so that the old one-line diagram will still work with the old case if you need to go back to it. Then you can open the one-line diagram, the new one-line diagram, normally with the new case. And then finally, if you're working with FERC 715 cases and also with some ISO issued cases like California ISO and a few others, we have an affiliate company called Energy Visuals. The contact information is listed down here, Tim Bourne. Here's the phone number and the URL if you want to go check out their website. And they have a product called Transmission Atlas, where basically they're building the one-line diagrams for you. They're geographic-based one-line diagrams. They build bus-based models and substation-based models, and they're updated as the cases in the FERC 715 series or in the ISO issued series are updated, and they'll give you cases that match, or they'll give you one-line diagrams that match the cases, so you don't have to worry about the renumbering. They also provide another product which is called First Rate, which provides generator cost models that can be used with the Optimal Power Flow add-on. If you need further support, please head to our website and check out the resources underneath the Online Support heading. If you are a current customer with a maintenance agreement, you can also call our office, email our support line, or if you prefer to work with a specific PowerWorld engineer, you can contact that person directly.